Today's April 28th, 2011. We're on the text page 243. That's where lesson 6.2 is. On your blue notebook, you're on page 343, the first one. There's a little error in your blue notebook. It says completing the square part 3, okay? And that's what I've called lesson 6.1 problem solving. So we're going to do a little problem solving with the method we learned yesterday, okay? So we're going to go over example 1. And in example 1, it says a rectangular lot is bound on one side by a river, and on the other three, and on the other three sides by a total of 30 meters of fencing. Okay, so what they're saying is we have some kind of rectangular lot. There is a river on one side of it. So consider this a bird's eye view. We're a bird looking down, okay? And we're looking at the lot, and we know that all of this black part, that's the fencing there, all the fencing adds up to 30 meters, okay? So that means our total fencing we've used is 30 meters, okay? We have 30 meters of fencing. Now, we know it's a rectangular lot, so we know that these two sides are going to be the same. Now, I could have drawn this rectangular lot maybe like this also. We don't know what it is yet. There's many different options. Oops, that was supposed to be blue. There's many different options, okay? It could be something like that. But we do know that the two sides that do touch the river, they're going to be the same length. So we're going to call those X, okay? So these will both be X. In this case, it could be X also here. Now we don't know what the other one's going to be. We can give it any other variable we like, okay? We don't know if the one side's twice as long as the other. They haven't given us any information like that, okay? So let's call it Y for now. Now we know all the fencing we used, or our perimeter, is 30 meters, okay? We know we have 30 meters of fencing, and we need to find, it says, what is the maximum area? Okay, in order to find area, what's our area formula? Length times width. So we have our area is equal to length times width, okay? L times W. In this case, we're going to call our length Y. So our Y will be our length, and our width will be our X. So our formula gets changed. Our area is going to be equal to Y multiplied by X. Okay? Whoa. Okay. So we have our area here, and we have our perimeter. Okay, let's also recall our formula for perimeter, okay? What would our perimeter be in this case? Anyone know? That's right. Because we have three sides of fencing here, we have our perimeter will be X plus Y. Okay? We don't know how long the lengths are, so we've given our variables. Now I can simplify this. 2X plus Y. Okay? And I do know my perimeter is equal to what? 30. 30 meters of fencing here. Okay? So our 30 meters of fencing, we can substitute that in for our P. So what I'm going to get you guys to do is quickly come up with a bunch of different answers you could possibly have. One example of this is, let's say you use, for some reason, that this is only going to be 1 meter long, and this is 1 meter long. That means I've used 2 meters of fencing. How much fencing would be left for Y? 28, okay? So if my Y was 28 and my width of my fences were 1, what would the area of this rectangle be? 28, that's right. So my area in this instance would be our Y is 28 and our X is 1. So in this case, area is 28. I want you guys to just make a small chart because we're going to do a little experiment with this. Oh, my math tools are there. Okay, so a way to do this is I want you to organize this chart. We have our possible lengths, our possible widths, and I'm just going to put X and Y beside them because we had renamed those variables. and our areas, okay, what our possible areas are. Now we remember we have a maxed perimeter of 30. So the first one I did, I had my length at 28 and my width was 1. In that case, I got 28 and 1, okay? Another one you could think of, if my widths were both 2, if both my widths were 2, so let's get rid of these ones here. Two and 2. How long would my y be? 26, that's right. I've used 4 meters of fencing in that other case. So I'd have 2 and 26. What would the area be in this case? 52. Okay, I want you guys to go down this chart and fill it out. Go from one end to the other. Okay? Give me all the possibilities. I want you guys to see what all these coordinates end up being. I'll give you about 5 minutes to try it now. Okay, so I'll give you guys 5 minutes to fill in this chart here. If you guys look, we have a whole ton of numbers. Made a little mistake here. What we're looking for is a max area, okay? So we knew we had 30 meters of perimeter. Our max area, it looks like I have 2 numbers that are the exact same. I have 112 and 112. They're both the 2 highest numbers. Now, in a parabola, there's only one vertex. And the numbers I had in there, I'm just going to clean them up a little so you can actually see what they were. Okay? We had 16 and 14 and 7 and 8. Well, what this probably means in a parabola, I'm going to use a little logic here. If I were to graph this, what that means is I'm going up like this, and I'm probably hitting a point here and a point here. I don't have my peak, though. There is only one peak. There is one high point. So I'm going to go in between these 2. So in between these, we have 7.5. And what would that give us for length? 15, right? 15 times 7.5, what would our area be? 112.5. Okay, so going through all of these numbers, we discovered that if I had a length of 15 and a width of 7.5, my area would be 12.5. That's a lot of work. There is a faster way to do this. I'm going to deal with it right now, okay? So, let's recall we had our perimeter, which was 2x plus y. We had given our, quickly draw this out again, here's our water, x and y. And we had our area, which was x times y. You knew that. We also know that the perimeter is equal to 30. So I'm going to substitute 30 in for the perimeter. So that's going to give me, and we're going to work with this specific equation. 30 is equal to 2x plus y. Okay? Now, what I need to do is not fall, and I need to make a quadratic equation. Okay? So, if you guys remember our quadratic equations, our standard form deals with an x squared, x plus, we have an ax squared plus bx plus c, right? So essentially, I need to find some x's. We know that it's equal to y normally, or f, oh no, that's not this class. Y is equal to ax squared plus bx plus c. Okay, what I'm going to do here is I want to be working with x's. I need to create an x squared somehow. So what I'm going to do, so I'm going to take this equation right here, okay? I'm going to set it equal to y. When I set it equal to y, if you guys remember from earlier chapters, I'll then be able to substitute it in for the y in the area formula. So I'm going to bring the 30 over, which will give me plus y, negative 30. I'm going to bring the y over, which will give me negative y equals 2x minus 30. And I need a positive, if you guys notice. It says positive y. So I'm going to have y is equal to negative 2x plus 30. So I now have a value to substitute in for my y in my area equation. Okay? So let's get our area equation. A is equal to x. And instead, I'm going to substitute this in for y because we know it's equal to y. So I now have negative 2x plus 30. Okay? I'm going to distribute the x. So I'm left with negative 2x squared plus 30x. Now, if you notice, I don't really have a value for c, but that's okay. Technically, this is still a quadratic equation. C is just 0 in this one. If you guys notice, I have a value for a, which is negative 2, and a value for b, which is 30. I'm trying to find a maximum. A maximum is the vertex of a parabola. So, to go, remember, we're in standard form. We learned that yesterday. This is considered standard. Okay? I need to put this into vertex form. So to go into vertex form, we learned it yesterday, we need to complete the square. So my very first step is I'm going to take out this negative 2. Divide the first two terms by negative 2. So I'm left with x squared and negative 15x. I don't have anything for a c right now. That's fine. Well, I now take this value, my negative 15, and we plug it into the little formula we had from yesterday, b divided by 2 squared. So I'm left with negative 15 divided by 2, which is negative 7.5 squared, which is 56.25. Can you believe I did that in my head? No, I didn't. That's a lie. Okay. So this is the number we're dealing with, 56.25. That means, if you guys remember I told you, we got to just keep doing that same pattern over and over again. We need to put 56.25 into this equation. So let's rewrite it. Negative 2 x squared minus 15x plus 56.25. Subtract 56.25. Remember, we do both because technically I'm not changing the equation. I'm adding and subtracting the exact same amount. Okay? I'm still trying to go through my vertex form, so I have to create a perfect square trinomial. So I'm going to move this negative 56.25 to the outside. And when I move it to the outside, I have to multiply by the number in front. So I have negative 2 x squared minus 15x plus 56.25 plus a negative times a negative, 112.5. Now, if you guys know from above, this 112.5, we go up here, that was what we found our maximum area to be, right? Which would make sense. Our maximum area would be the y value of a parabola when we try. But I actually need to find what the x and the y are, the length and the width. So I'm going to finish completing the square. Negative 2. Square root of x squared is x. Square root of 56.25. Who knows what it is? 7.5. That's right. Right? So we have our 7.5. And because there's a negative sign, I put the negative down there. Remember, the sign of the second term is what we bring down. Plus 112.5. Now remember, we were finding area. So this says area equals. It's not y equals. I don't want you to make that mistake. Okay? So if I was to quickly graph this. Okay. So here, I quickly made a graph. And we're in vertex form, so we know that this says negative 7.5. So actually move over 7.5 to the right. That's going to be somewhere around here. Oh, shoot. I need to go up to 112. I drew the wrong line. Okay, so if we quickly draw the vertex, we're at 7.5 and 112.5. That's, I don't know, somewhere around here. Okay? And we have a graph that's going down, something like this. We have 7.5 is our x and 112.5. Well, 112.5 is our max area. This is my x value. I still have to discover my y value. So I take that 7.5 and I plug it back in to our other equations. Okay, so I did this two different ways. Either way will work. The first way I did the perimeter formula, substituted 30 in for p, 7.5 in for x, and I calculated for y. Y ended up being 15. The other one, doesn't matter which one you choose, works. Area. I plugged 7.5 in for x, solved for y. Y ended up being 15.